In the cold, heaving darkness of the North Atlantic, the war was often decided in the silence between waves, but more accurately, it was decided by the moments when that silence was broken. For the men inside the iron pressure holes of the German U-boat fleet, the radio was their lifeline and their greatest liability. It was the tool that allowed them to hunt in packs, swarming Allied convoys with coordinated ferocity. But it was also a beacon that could scream their location to the enemy. Admiral Karl Dönitz, the architect of the U-boat arm and the mastermind of the Wolfpack strategy, was a man of cold calculation and precise variables. He had built his entire naval doctrine on a specific mathematical assumption regarding the safety of these radio transmissions. He believed, based on the best intelligence available to the German High Command, that a submarine commander was safe if he kept his message brief. The magic number was 30 seconds. If a transmission lasted less than half a minute, Dönitz assured his captains the enemy's direction-finding equipment could not get a fix. This belief was not merely a guideline, it was the foundation of German naval survival. It was also a catastrophic error that would cost the lives of thousands of men. That the German confidence was rooted in a misunderstanding of the enemy's technological timeline. Before the war, radio direction finding was a clumsy, mechanical affair. To find the source of a signal, an operator had to physically rotate a loop antenna, listening for the point where the signal strength dipped to zero, the null point. This mechanical process took time. The operator had to sweep the antenna, fine-tune the angle, and read the compass bearing. Under the best conditions, with a skilled operator, this took nearly a minute. Under combat conditions, it could take longer. Therefore, the German logic was sound, provided the enemy was using the same technology. To exploit this perceived window of safety, the Kriegsmarine developed the Kurzsignale, or short signal system. Complex operational data location, convoy speed, where the fuel status was compressed into 4-letter codes that could be tapped out in Morse. Bursts lasting only 15 to 20 seconds. Dönitz and his staff did the math. If the enemy needs 60 seconds to find us, and we are on the air for 20, we are invisible. What Dönitz could not conceive, and what his intelligence officers failed to uncover until it was far too late, was that the British were not using the rotating loops of the 1930s. They had leaped a generation ahead in electronic warfare. Years before the first shot of the war was fired, a British physicist named Robert Watson Watt, the same mind that would give Britain radar, had applied his genius to radio direction finding. He realized that mechanical movement was the enemy of speed. He replaced the physical rotation of the antenna with the electron beam of a cathode ray tube. In the British system, known as high-frequency direction finding, or HFDF, colloquially, Huff Duff, the radio waves from the U-boat hit a fixed antenna array. The signal was instantly converted into a visual display on an assist. There was no waiting, no turning of wheels, no listening for a null. The moment the Morse key was pressed in the Atlantic, a line of light flashed on a screen in a British listening station. The angle of that line was the bearing. It happened at the speed of light. The British did not need 60 seconds. They did not need 30. They needed a fraction of a second to see the signal, and perhaps 5 seconds to read the bearing. The margin of safety Dönitz had promised his crews did not exist. Every time they touched the transmit key, they were painting a target on their own backs. This technological mismatch created one of the most lopsided intelligence victories in military history. Yet it remained a secret war fought in the ether. From the onset of hostilities in 1939, a vast, invisible net was stretched across the Atlantic. The British established a chain of shore-based Huff Duff stations extending from the granite cliffs of Cornwall to the windswept coasts of Scotland, Iceland, Greenland, and Newfoundland. Eventually, this network grew to include stations in Bermuda and Canada, creating a comprehensive ring around the operational areas of the Wolfpacks. When a U-boat surfaced to report a convoy sighting, its signal did not just travel to German headquarters in occupied France. It washed over these listening posts simultaneously. At a station like Bower in the Scottish Highlands, a young operator, often a woman from the Women's Royal Naval Service, would see the flash on her screen. She would mark the bearing and telephone it immediately to the Admiralty in London. The true power of this system lay in triangulation. A single bearing is just a line on a map. It tells you the direction of the enemy, but not his distance. But when 5 or 6 stations across the Atlantic captured the same signal, their bearing lines converged. In a subterranean bunker in London, known affectionately and grimly as Len's Tomb, These lines were plotted on a massive chart of the Atlantic. Where the lines crossed, a small polygon formed. That was the U. While a single long-range bearing might have a margin of error of 50 miles, the statistical average of multiple intercepts could pinpoint a submarine to within 10 to 20 miles. This was strategic intelligence of the highest order. It allowed the Admiralty to see the wolf packs assembling before they even struck. It allowed them to route convoys through the gaps in the German patrol lines, turning the ocean into a giant chessboard where the Allied pieces could see the enemy's moves in real time. For the first years of the war, this strategic evasion was the primary defense. The convoys simply sidestepped the danger. The Germans would form a patrol line, waiting for days for ships that never came, unaware that their own daily status reports were the very thing diverting their prey. Dönitz was baffled. He frequently complained that the ocean seemed empty, or that the British possessed an uncanny ability to predict his movements. He suspected treason. He suspected spies in the French ports. He suspected airborne reconnaissance. He even asked his intelligence chief, "Is it possible they are reading our Enigma codes?" The answer, delivered with dangerous certainty, was always no. The Enigma machine was mathematically unbreakable. The Germans checked their procedures, tightened their discipline, and continued to transmit, never suspecting that the vulnerability was not in the encryption of the message, but in the transmission of the signal itself. While the shore-based stations provided the strategic picture, the tactical war, the bloody close-quarters battles around the convoys required something more immediate. Strategic plotting could tell a convoy commander that a U-boat was 20 miles away, but it couldn't help a destroyer captain find a submarine hiding in the fog a mile off his port bow. The solution was to shrink the technology, to take the sensitive, bulky laboratory equipment of the shore stations and shove it into the cramped, damp, violently pitching operations room of a convoy escort vessel. This was an engineering nightmare. A steel ship is a forest of metal masts, wires, and guns, all of which reflect radio waves and distort bearings. It was believed impossible to put an effective Huff Duff set on a warship without the ship's own superstructure, rendering the data useless. The breakthrough came from a Polish engineer, Wojciech Straszewski, who had escaped to Britain and joined the Admiralty signal establishment. Straszewski designed a revolutionary antenna and a correction system that could filter out the interference caused by the ship's own mast. His work allowed the installation of Huff Duff sets on frigates, corvettes, and destroyers. This was the moment the balance of power shifted irrevocably. By 1942 and early 1943, escorts were being fitted with these sets. Now, the trap was complete. When a U-boat spotted a convoy, his duty was to transmit a sighting report, to gather the rest of the wolf pack. He would surface, unaware that the innocuous-looking destroyer on the horizon was listening not with ears, but with an electronic eye. The moment the German operator tapped out his four-letter code, the oscilloscope on the escort lit up. The British operator would shout Huff Duff contact, and read off the bearing relative to the ship's bow. The tactical counterattack was brutal and immediate. The escort commander would ring up full speed and turn the ship down the bearing line. The U-boat captain, seeing a destroyer charging at him out of the mist just seconds after he began transmitting, had only one choice: dive. This was the genius of the Allied tactic. The destroyer didn't necessarily need to sink the submarine to defeat it. By forcing the U-boat to dive, the escort blinded it and slowed it to a crawl. On the surface, a U-boat was faster than many convoys, capable of 17 or 18 knots. Submerged, it was reduced to a creeping 4 or 7 knots. Unable to keep pace with the merchant ships, the shadower lost contact. The chain of information to the rest of the wolf pack was broken. The convoy would alter course, vanishing into the ocean wastes, while the blinded submarine groped uselessly underwater. Without the radio beacon to guide them, the other U-boats in the pack would fail to converge. The attack would disintegrate before it began. The synergy between Huff Duff and the breaking of the Enigma cipher created a comprehensive intelligence picture that was without parallel in the history of warfare. They were the two eyes of the Allied intelligence beast. Enigma, the ultra-intelligence, provided the intentions. It told the Allies what Dönitz was planning, where he was ordering his boats to go, and how many were operational. But Enigma had a lag time. Decrypting the complex naval cipher could take anywhere from 24 hours to 3 days. In a fast-moving battle, Enigma was often historical data. Huff Duff, by contrast, was instantaneous. It provided the now. It told the commanders exactly where the enemy was at this second. Furthermore, Enigma was fragile. When the Germans changed their cipher keys or introduced an extra rotor to the machine, the Allies could be blinded for weeks or months. During these blackout periods, Duff became the only thing standing between the convoys and annihilation. It worked regardless of the code being used. It didn't matter if the message was encrypted in Enigma, Morse, or pure gibberish. If it was a radio wave, Duff could point a finger at it. The climax of this technological war arrived in the spring of 1943, a period that would decide the fate of the Atlantic crossing. In March of that year, the German U-boat arm seemed on the verge of total victory. They sank nearly 500,000 tons of shipping in a single month. The supply lines to Britain were straining to the breaking point. The Allied leadership was despondent, fearing that the convoy system itself had become obsolete in the face of the Wolfpack efficiency. But the Germans were unaware that the seeds of their destruction had already been sown. The proliferation of shipboard Duff, combined with the closing of the air gap by Liberator aircraft and the arrival of support groups freelance hunter-killer naval units, was about to trigger a reversal of fortune so sudden and severe that the Germans would never recover. May 1943 became known as Black May to the U-boat crews. The hunters became the hunted with a vengeance. During the battle for convoy SC-130 in mid-May, the full lethality of the integrated Allied defense was unveiled. Dönitz threw 33 U-boats at this convoy. In the past, such a concentration would have resulted in a massacre of merchant ships. Instead, it resulted in the systematic execution of the U-boat force. Every time a submarine surfaced to coordinate the attack, it was pounced upon. Shore stations detected the initial concentrations and warned the escort commander, Peter Gretton. As the U-boats closed in, the shipboard sets on Gretton's destroyers picked up individual transmissions. Escorts raced down the bearings, forcing boats under or blasting them with depth charges. Aircraft, guided to the scene by the same radio beacons, dropped out of the clouds to strafe and bomb surfacing submarines. The breakdown of the German command and control was absolute. The Wolfpack relies on chatter. It relies on a web of signals to swarm the target. Duff turned that web into a trap. In the battle for SC-135, U-boats were sunk. No merchant ships were lost. Among the dead was Peter Dönitz, the Admiral's own son, serving on U-954. The Admiral received the news but pressed on, unable to grasp why his tactics were suddenly failing so spectacularly. By the end of May, the Allies had destroyed 41 U-boats, a quarter of the entire operational fleet, in just 31 days. It was a slaughter. Dönitz, stunned by the losses, withdrew his boats from the North Atlantic. He admitted in his diary that they had lost the Battle of the Atlantic, though he clung to the hope that new weapons would turn the tide. They never did. The tragedy of the German defeat lay not just in the loss of life, but in the persistent, stubborn ignorance of the cause. The German High Command conducted inquiry after inquiry. They looked at the wreckage of their strategy and asked, "How are they finding us?" And time again, they exonerated the radio. They obsessed over the idea of Allied radar. They believed the Allies had developed a radar so powerful it could spot a conning tower from 30 miles away. They issued orders to coat the submarines in rubber to absorb radar waves. They installed radar detectors. They blamed spies. They blamed treason. But they refused to abandon the belief that a 20-second radio burst was safe. They were prisoners of their own pre-war assumptions, unable to imagine that the enemy had solved the physics of instantaneous direction finding. Even when they found evidence, they misinterpreted it. In August 1943, a German order finally acknowledged that the Allies might be using direction finding more effectively than anticipated, but the order revealed a profound misunderstanding. It claimed the enemy was using direction finding to guide aircraft, but assumed the accuracy was still poor, 50 to 60 miles, and that radar was doing the final pinpointing. They did not understand that a support group of destroyers could triangulate a U-boat to within a few hundred yards purely on radio emissions. This misunderstanding was fatal. It meant that German countermeasures were always insufficient. They introduced burst transmitters late in the war that could send messages in a fraction of a second. But it was 1944, and the war at sea was already lost. The experienced crews who might have utilized such technology were already at the bottom of the ocean, victims of the years of 20-second transmissions. The role of the support groups cannot be overstated in this phase of the war. These were squadrons of destroyers and sloops that were not tethered to the slow pace of the merchant ships. They were free-ranging predators. When a Huff-Duff contact was made, a support group could detach and hunt the contact relentlessly. They utilized a tactic known as the hold-down. If a U-boat was detected and forced to dive, the support group would sit on top of it. They didn't simply drop depth charges and leave. They waited. They knew the U-boat had limited oxygen and battery power. They would circle the area for 20, 30, 40 hours, pinging with sonar, waiting for the inevitable moment when the submarine had to surface for air. When it did, the guns were already trained on the spot. This transformed anti-submarine warfare from a defensive struggle to protect cargo into an offensive war of attrition to kill crews. The psychological impact on the U-boat crews was devastating. They began to feel that the ocean itself was transparent. Survivors spoke of a sense of claustrophobia, a feeling that there was nowhere to hide. They would surface in the middle of the vast Atlantic, thousands of miles from land, believing they were alone, only to see a Liberator bomber diving at them out of the sun, or the mast of a destroyer cresting the horizon. The morale of the U-boat arm, once the elite of the German military, began to crack under the strain of fighting an omniscient enemy. The casualty rate climbed to 70%, the highest of any service branch in any nation during the war. To board a U-boat in 1944 was essentially a suicide mission, yet they continued to sail, and they continued to use their radios, following orders that had been obsolete since 1939. Following the war, the extent of the German blindness became fully apparent. At the Nuremberg trials, Admiral Dönitz defended his conduct of the naval war. He spoke of the unbreakable enigma and the safe short signals. He went to his grave largely believing that it was radar and air power that had defeated him. The British, for their part, kept the secret of Huff-Duff and ultra-tightly sealed. It was not until the 1970s that the full story of the electronic war was declassified. Only then did historians and surviving veterans realize the magnitude of the disparity. The Germans had been fighting a war of visually sighting targets and mechanically calculating angles, while the Allies were fighting an electronic war of instantaneous detection and information dominance. The statistics of the victory are stark. Huff-Duff was directly or indirectly involved in the destruction of nearly a quarter of all U-boats lost in the war. But its impact goes beyond the kill count. It was the force multiplier that made every other weapon effective. A depth charge is useless if you don't know where to drop it. A convoy escort is useless if it is on the wrong side of the merchant ships. Huff-Duff put the weapon on the target. It took the vast, trackless expanse of the Atlantic Ocean, millions of square miles of hiding places, and shrank it down to a grid of deadly precision. It negated the primary advantage of the submarine, stealth. In retrospect, the defeat of the U-boat peril was not just a victory of industrial capacity or sailor courage, though both were essential. It was a victory of intellectual flexibility over rigid dogma. The German Navy checked its math, found it correct, and stopped asking questions. The British Navy looked at the problem, realized the old math would lead to defeat, and invented a new calculus. They integrated scientists with soldiers, placing civilian intellectuals like WWII in operational command of the submarine tracking room. They allowed a Polish engineer to redesign the masts of their warships. They empowered junior officers to install experimental equipment on their own initiative. This culture of innovation, contrasted with the rigid top-down authority of the German command, proved to be the deciding factor. Ultimately, the silence of the sea was an illusion. The airwaves were screaming with information. The Germans shouted into the void, believing no one could hear them in the brief moments they spoke. The Allies listened to every word, measured every signal, and plotted every death with cold, electronic precision. The Battle of the Atlantic was won not just by the convoys that got through, but by the transmissions that were intercepted. It was a victory of the electron over the wolf pack, a testament to the fact that in modern warfare, what you don't know and what you think you know for sure is far more dangerous than the enemy you can see. The U-boat crews died because their leaders confused confidence with competence, and in the unforgiving arena of the North Atlantic, that was the one mistake that could not be forgiven. The final irony is that the tool that defeated them was physics, simple and immutable. A radio wave travels at the speed of light. To base a strategy on the human reaction time of 30 seconds was to ignore the fundamental nature of the electromagnetic spectrum. Dönitz bet his fleet on the hands of a clock, while his enemies were fighting with the speed of lightning. The result was the destruction of the Kriegsmarines, undersea ambition, and the preservation of the lifeline that allowed the liberation of Europe. The ghost of the U-boat fleet lies on the bottom of the Atlantic, a monument to the fatal cost of a wrong assumption.